My Wi-Fi is going in and out again. Oh no, so just make sure that you guys sign in, okay? So if your Wi-Fi goes cranky, at least you or your attendance is accounted for. Yep. How do I get there? Hi, Jacob. Jacob, if you go to Schoology, right where you access your Zoom link, it's right here. Sign in for attendance. Yep. Okay, and I put the meeting ID back in the link. I took it out because remember when we had that incident where I thought, you know, maybe having the meeting ID there just makes it accessible by anybody. So I put it back because I realized some of you are putting that directly into the lausd.zoom.us, and I did not even think of that the first time, you know. So I thought you were just like clicking on the link. So I put it back right there. Okay. Good morning, everybody. So whatever you guys are doing right now, maybe just make sure that you find ways to kind of tune in um, and learn as much as we can. All right. Okay, here we go. So last time we were doing exponents, right? We used a calculator to answer some of the Schoology questions. I know a lot of you got 7/7, and you guys were so happy, you know. So that's good. That's good. So today we will do still on exponents. We'll still work on exponents, but it will be graphing functions with exponents this time. Okay? All right. So again, just be ready with a paper and pen in case you find it hard to write on OneNote. Otherwise, I think we're good to go. We're just gonna annotate on the text. Okay, so first, what is the parent exponential function? So parent function is just a fancy name for saying, you know, this function is the most basic one. Just like when we were doing linear functions in the first semester, right? So parent function is the most basic one that everybody should know about. So whether you go to higher math or you don't go to higher math eventually, you still have to know what the parent exponential function is. So are you ready? Double click. Okay, double click over here so we can type in our answers. Okay, with or without your calculator, what is the value of y when x is 0? Maybe I need to write on the side so you guys can visualize that as well. So the function is y equals 2 to the x. And the first value we're substituting is 2 to the 0. So can you tell me what 2 to the 0 is in the chat pod? If you're not sure, you can use your decimals calculator. You remember that? Should we open that? The one you used in the Schoology work last time? 1! Very good, William! Awesome, honey. Let's put 1. So anything raised to 0 is actually 1. If you guys, week 4, honey. Yeah. All right. Okay, so next one. What is y equals 2 and then to the first power? You can see this is x is equal to 1. Type your answer in the chat pod. What is what? Okay, very good, Juliet. That's 2. Okay, let's keep typing over here. Okay, can you type and then I'll just write on the side because I feel like, okay. All right, so whatever answer I show here, you type it in here, okay? All right, because I need to like switch from a pen to a mouse. Okay. All right, here we go. Next. How about 2 raised to the second power? 2 raised to the second power. So you type, I will write, okay? So 1, 2. 2 to the second power. It means you gotta go 2 times 2. 4. You guys agree with Juliet? Oh, Leia, I didn't see your answer earlier. That's a good one, honey. Um, Juliet, that's great. Anybody else who agrees with Juliet? If you agree with Juliet, type 4 in the chat pod. Otherwise, type in whatever answer you got. Hey, Brandon. I'm sorry you missed the office hours yesterday, honey. Yeah, but I do understand. Uh-huh. Try to set up another one maybe next week. Okay, honey? What food did you get for yourself and your sibling yesterday? I was waiting for you and then you said, Miss, I couldn't make it. I had to go get food. It was like, aw, you made me hungry. Taco Bell, alright. Nice one, honey. Okay. So next time just set up, a day that's convenient for you, okay? Alright, so 2 squared is 4. That's awesome. Next, 2 to the third power. Except Fridays, by the way, Brandon, because I have a mentoring meeting on Fridays. And George said it's 8. That's perfect, George. Am I loud? Sorry. Well, you're my first class. Every even day, so. Okay. 2 to the fourth power. What would that be? 2 to the fourth power. 2 to the fourth power. Anyone? 16. Very good, George. Okay, I'm going to erase the work over here. And I'm going to ask you, without doing the work, can you tell me what's going on? Like, oh no, what am I doing? Okay. Alright, I did something wrong. Okay, so without actually showing all the work that we did here on the left hand side, is there a way you can actually find a pattern to fill up the table? Look at this one. If the base is 2, can you tell me how that base is related to how the table is growing over here? By how much are the y values increase as your x values add 1? So as the x values increase by adding 1, by how much are the y values going up each time? Like how does a 1 turn to a 2, and a 2 to a 4, and a 4 to an 8, and an 8 to a 16? Can you find like a common number that's being multiplied or divided to the previous one to get the next one? By 2. Very good, George. So using your answer, can you predict what the next number after 16 here will be? What will be after 16? What will be after 16? 32. Good job, William and Henry. Yes, so even without showing that, all the work that we wrote out earlier, you can actually find a pattern. And the pattern is you identify the base, right? And that's the number you're going to multiply to find the next number. Okay, so let's explain this one here. As x increases, can you type in that bubble? Just double click inside that bubble and you can type, yeah? So you go like this, and then a text box will pop up. You see that one? And that's how you type. Or you can just move it up, okay? I'm just going to write so I don't have to, switch from mouse to pen. It's just kind of confusing. Okay, so as x increases by 1, the y values double, right? Okay, as x increases by 1, the y values double. Now, why do they double? Because, excuse me, because the base is 2. Let's graph that, shall we? Okay, let's graph 0, 1. So 0 is in the middle, and then you go 1 up. How do you do that on your OneNote? You remember you can go to draw, and then you pick the pen, you pick whatever color you want, and if you want to make the dots more visible, you change the thickness, so you can place dots like this, okay? Alright? If you want to erase, you go to the eraser, and just click, 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 and so on. Okay. All right. You ready with that? Okay, so let's graph it. So 0 for x, 1 for y. Let's keep going. 1 to the right, up 2. 1 to the right, up 2. Okay, next. 2 to the right, up 4. So 1, 2, 1, 2, 3, 4. Do they look like it's a straight line? Okay, well, let's try next. 3, 8. So up 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. All right. And let's do the last one. 4 to the right. 1, 2, 3, 4. This was 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. Okay. That hurt my eyes. All right. There you go. Now, in the chat pod, can you describe to me how the shape looks like? Is it a straight line or a curve? So type either straight or curve. Is the graph straight or curve? Juliet said curve. What about the others? What did you guys get? If you did not graph it, can you at least type in the chat what you see on your screen? Is it curve or straight? William said curve. What about the others? Curve. Very good, Leah. George. Oh no, what happened to your graph, George? Maybe we need to redo the dots, George. Because if we connect the dots, honey, they're gonna go like this. Ooh. Or maybe you haven't finished graphing all of them. If you stop at 2, it will look like it's kind of curved. Oh, I get you, George. Yeah, if you're doing it on paper, if your y-axes are not evenly spaced, it might create that impression that it's straight, but it's actually not. Hi, Cicely. Yes, honey, you can do it on paper if you want to. Uh-huh. And I heard that's what some people are doing. Like they also, you know, they write on their paper and then they take a picture and upload it on their notebook. But that's optional. Do whatever works for you. Okay. All right. Okay. So that's the graph of the basic exponential function, the parent exponential function. Okay, so how can we identify the type of function that's represented by a table? So today here we said that, oh, this is exponential because the numbers get multiplied by 2. But if you look at the next line over here, you have to identify whether a table is linear or exponential. Okay? So I'm going to clear these ink. If you missed something, you can watch the screencast later on. I'm pretty sure it captured everything. So how do you know if it's linear or exponential? And determine whether, and you have to explain why. Explain why. Okay? So let's try. So if you look at all the x columns, all of them are increasing by 1, right? So I guess we just have to kind of focus on the y column. Now look at this. By how much are your y values being multiplied or divided? By how much are your y values multiplied or divided? Number 1. By 2. Did you say multiply by 2 or divide by 2? All right, Henry. Nice one. So, in other words, if you're dividing by 2, you're multiplying by 1/2, right? Or divide by 2. Okay, so since you're multiplying by 1/2 or you're dividing by 2, then this is exponential. Okay, now I'm gonna include some fancy terms right here. If the numbers are going up, you call that one, the growth rate because the numbers are growing, right? Okay, but if the numbers are going down, okay, you may call that the rate of decay. Decay means it's going down, right? So the rate of decay is 1/2, or you divide by 2. Okay, so like this COVID virus during this pandemic, you think the type of function it represents is linear or exponential? What do you guys think in the chat? Type in the chat pod. You think the this pandemic is growing on a linear function type or an exponential type of function? Well, how do you know? Linear is, for example, here number 2. Linear. So Leia, you said number 2 is linear? Or the pandemic is linear? Okay, so 3 going to 7, that's add 4, right? Okay, then 7 to 11, that's add 4. And then 11, 15, that's add 4. So linear means there's only like a certain number that gets added every day, right? But exponential means the number could double, could triple, or could be multiplied 1,000 times the following day. I think yeah, it's an understatement if we say this pandemic is going linear. We probably should still be in school if it's growing linearly, right? It's been growing exponentially. Like it increases by what, more than 40,000, or more than how much in some countries, right? Okay, so this one is an example of a linear because you're just adding a number each time. Okay, so the slope here, the slope is 4. Remember when we were doing y equals mx plus b? The common number being added or subtracted is the slope. Okay, so do you see the difference between the two? If you divide or multiply, it's exponential. Okay, but if you add or subtract, it's linear. If the change can be, if the change is a number is being added or a number is being subtracted, it's linear. Number 3. What's your answer to number 3? From 12 became 9, 9 became 6, 6 became 3. Is that linear or exponential? What do you guys think? Type in the chat pod. Linear. Yes, very good. Because the difference is you're subtracting 3 each time, right? Yep. So this is linear. And the slope is -3. Uh-huh. All right. So George, a function is exponential when you can find a number that you can divide or multiply, okay, to a previous number to get the next one. Like 8 divided by 4. I mean, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. But if you're just subtracting, 12 minus 3, 9. 9 minus 3, 6. 6 minus 3, 3. That's linear. Okay, one last. If the decimals are throwing you off, maybe start from here. How do you change a 2 to an 8? How can 2 become an 8? The chat pod times 4. Very good. So now let's see if that works for the others, William. Help me with this. If you times 0.5 by 4, will you get 2? So think of that in terms of money. If you have 50 cents or Yeah, right? If you have 50 cents, you times that by 4, would you have $2? What do you think? So did it work? Yes or no? Yeah. Okay, cool. What about this? If you multiply 0.125 by 4, would you get 0.5? So why are we checking? Because one ruins it for all. It could be, neither linear nor exponential. That's possible. Okay, so is 0.125 times 4 0.5? Yes, very good. So this is exponential because we found out that 4 could be multiplied to the previous one to get the next y value. So this is going up, right? So we say the rate of growth is times 4. Okay, so when we say slope, you're adding or subtracting that. If it says rate, you're multiplying or dividing. Okay? Another term that they use, aside from rate, is the word factor. So you could say the growth factor, okay, or decay factor. They mean the same thing. Okay, next, we're going to practice how to evaluate exponential functions. I have here y is equal to 3, and then you have an exponent x, you replace x by 5. Can you tell me what the final answer for that will be? What's the final answer for that one? 3 to the 5th power. You can use your calculator or you can do it in your head. Juliet said 243. Because this means you're going to multiply 3 by 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Okay, next one. Suppose I have y is equal to 1 over 4, and you have to raise that to the 3rd power. How would you do that? Remember, if you have a fraction, you can distribute the 3 to each of them. So you go 1 to the 3rd power over 4 to the 3rd power. Or you can also write 1/4 3 times. There you go. So either way, what will be your final answer? Type it in the chat pod. 1 over 164. Or 1 over 64. Good job, George. Awesome. All right, next. 7. Y equals, ooh, be careful with this. There's a 3 before the base. Okay, and we're changing the x to 4. Okay, be careful with this. You should not multiply the 3 to the 4 yet. Okay, remember your order of operations? You have to do the exponent first. Remember, PEMDAS, EMDAS. You have to do the exponent before you do any multiplication or division. Okay, so let's do 4 to the 4th power first. That will become 3 times, can you help me out? What is 4 to the 4th power? 4 times 4, 16, times 4, 64, times 4 is 200, what? 256. Very good. And that's the only time you can multiply the 3 to the 256. So what would that be? 256 times 3 will be 700, what? In the chat pod? 768. Very good. So 768. All right, you would get a different answer if you multiply these two first. That would be wrong. Okay, so far, what have we learned so far? We've learned how to identify whether a function or a table is exponential or linear. We have also learned how to evaluate, meaning find the value when x is equal to a certain number, right? So also we did graph the parent function. So what we're going to do next is look at some more graphing, but this time it's not just the parent function, but any graph in general. Okay, all right. So if you're writing this on paper, I suggest you also write down this one, the definition here, or the explanation of the function, okay? All right, but do know that anytime you need to refer back to your notes, they're just in your Schoology or OneNote. Okay, so first, let me explain what the letters are for. You have a function y, which is equal to a constant a, can go up for a second. Oh no, I already cleared it, Leia. My bad. What was the last one again? It's in the chat. 768. Juliet typed it in the chat. Yeah. Uh-huh. Okay. So first we have a times b to the x. And I prefer if b is in the parentheses if you're graphing for the first time because you might get confused. Uh-huh. Oh, did somebody chat me privately? How can I see the video record? Where can I find it? Really? You haven't seen any? It's it's in your Schoology. Like for example, our video from last week, it's right here. You see that one? If you open that page, it's going to like play right there. See? Yeah. So you can listen to my, to the screencast or recording if you miss anything. All right? I know. When are you going to post this one? Oh, I posted like right after. Yeah, right after. I uploaded to YouTube so it doesn't take up space in my drive. And then I post the link in Schoology and then it loads automatically. Yeah. Okay. So, or subscribe to my channel. Okay, here we go. So y is equal to a times b raised to x. Yeah? So a is very important. This is your initial number. Initial number. Oh no. There you go. Okay? And b is the number you multiply or divide. Multiply or divide. Remember in the first graph we saw today, you said you're doubling it? Okay? So here, your base is still 2. So that means you're still doubling the value, right? But what's going to change now is that it has a number in front. So in other words, when x is 0, instead of beginning with 2, you're going to begin with 16. Okay, so what does that mean to you? What does that mean to you? It's like your, y-intercept when you're doing linear. So when you see a function like this, always, always, always look for a. Yeah? Always look for a. And how do you know the difference between a and b? Can you explain to me? Okay, so how will you know the difference between a and b? Like in this example, how would I know the difference between a and b? Is a always greater than b? Not necessarily. So can you tell me how you can spot an a versus a b value? Awesome! Say that one more time, honey. Did you guys hear what Henry said? You have to look for the exponent. The exponent always goes with the base. The number that doesn't have an exponent, that's your very first number. So if you're doing this in paper, go ahead, start writing. If you're typing, you gotta double click there again so you enter the values. So find the beginning number, which is 16. Now, do we have to do that much work again as we did earlier? No, not anymore, because you already see the pattern. You're doubling the pattern. You're doubling the number. So can you tell me what's next here? After 16, what's next? If you double. Ooh, George, be careful. Double means you times it by 2, not add 2. Remember when you're doing 32? Yes. Very good. 32. Next, you're going to keep doubling it. You double 32 again. What will be the next one? What's 32 times 2? 64. Very good, Brandon. Keep doubling it. Times it by 2 again. 64 times 2. 128. Very good, George and Sean. Keep doubling it. 128 times 2. 256. Very good. And last but not the least, keep doubling it. It's 512. Good job, Sean and Juliet. All right. Okay. So if I change the 2 to 3, then you're just going to multiply by 3, right? Okay. Next one. Oh, look at this. Your base now is 1/2. 1/2. So that means you're not multiplying by 2. You're now going to divide by 2. Okay? There you go. So you divide by 2 each time to get the next number. Now, can you tell me what's my beginning value again? What's my beginning value? 16. Very good. So you remember it, huh? Remember, it's the number that does not have an exponent. Good job, George. Okay, now you're going to keep dividing by 2 to get the next one. Divide by 2. What do you get? Divide by 2. What do you get? I'm sure you meant 8, right? Okay, good. 8. 16 divided by 2 is 8. Keep dividing by 2. What's the next one? 4. Very good. Keep going. Keep going. Keep going. Ooh. Try again. Try again. Oh, yeah. 2, 1, and then, yeah, William. Okay, 0.5. I think you entered like late. That's why. Okay. Question. Whenever b is a fraction, you gotta divide. Yes, if it's a fraction smaller than 1. Uh-huh. Yes, if it's bigger than 1, you multiply. Okay. Already, I'm going to clear this one. All right. Clear it. And here's just some notes right there. I listed down some properties. Okay. But we're going to talk more about this next time. I just want us to keep practicing so you don't forget what you guys learned. Okay, here we go. Do we have Delta Math today? I don't think I gave you one, honey. Yeah. Uh-huh. So the grades are due on Wednesday, so I want you to do any missing work that you might have, including Delta, but I'm not assigning a new one. Okay? All right. So let's practice what we just learned so we don't forget. Let's go here. All right. In exercises 8 and 9, we're going to graph the function. So first, let's make a table so we don't get confused when graphing. This is x, and this is y. And look at your function right here. Okay. Can you tell me what a and b are in this function? What is your a? What is your b? Remember, your original function is a times base to the exponent. So what is the value of a? -2. -2 to the x. Actually, it's +2 to the x, right? And then, what was multiplied before it? What was multiplied before? I'm late. Oh no. Okay, I'm sorry to hear that, Erlinda. Can I please talk to you quickly after class? Yeah, sure. Okay, so this was 2 to the x, right? So now there's a negative in front. So if it's negative 2 to the x, remember the parent function is positive, so it means they're multiplying here by -1. Now why is that important? Because remember your initial value? Even though there's no number before the 2 to the x, you still have to follow the sign, and that affects your initial value. Okay, so we start at 0, 1, 2, 3. Let's give 4 numbers. All right, so can you now tell me what your first value will be? What is your first value? Remember the first value, very good, George, it's the number before the base. Whether it's negative or positive, if it's an invisible, let's say negative times 2 to the x, then you gotta make it -1. Cool. Okay, so now your base is 2, and we've seen how 2 affects the numbers. We double, okay? All right, game. So double, -1, meaning you multiply -1 by 2. Answer in the chat pod. You multiply -1 times 2. -2. Very good. Keep going. Keep going, Brandon and Juliet. And the others too. Multiply this by 2 again. Multiply by 2. -4. Good job. Keep going. By 2. -8. Very good. By 2. -8 times 2. -16. That's great. Okay, so how does that affect our graph? Earlier, we saw the graph that was like going upward. Very good, Cicely and Brandon. So now let's make a graph with all those y values being negative. Let's do that. Okay. All right. So let's start graphing them. When x is 0, you go to -1. Place a dot. I don't know how you're graphing this. Can you let me know in the chat? You can say paper or OneNote. OneNote, okay, cool. Paper, good, okay, awesome. So just make sure you use whatever works for you. Okay, so from 0, you go down 1. Next, you go 1 to the right, down 2. Okay, next, 2 to the right, 4 down. 1, 2, 3, 4. Okay, next, 1, 2, 3 to the right, and then 2, 4, 6, 8 down. Though definitely we don't have space for 16. So your graph's going to go like this. All right. Okay. So maybe you're wondering what's going to happen on the other side of the graph. Okay. So what's going to happen on the other side of the graph? So if you can do something like this, extend that graph towards the x-axis, but don't cross it. Like that. So extend the graph, but never cross the x-axis. It will only get, it will only get closer and closer to x-axis, but we'll never touch it. All right. Okay, now let me share a fancy term for that one with you right here. I'm gonna go up a little bit, okay? It might move the ink, but I'll go back right here. Okay, so you see this word right here? Asymptote. Asymptote. An asymptote is a line that a graph gets closer and closer to but never touches it. Okay, so you call that an asymptote. Now, do all functions have asymptote? Not really. We didn't have asymptotes in the first semester, right? So this is the first time that we see an asymptote for a function. Okay, so now I can put my graph back to its original place, but there you go. All right, let's try another one, shall we? Let's do this. All right, so x, y. All right. Now, guys, in case you're practicing on, graphing and you want to check your work, if you go to desmos.com, the other one was desmos.com scientific, right? The calculator. But if you want to check your graph, you can use Desmos as well. Like we graph y equals negative 2 raised to x. Yeah? So you see the graph right there? Okay, so it gets very close to the x-axis, but never touches it. You see that one? When x is negative 7.1, your y is negative 0.007. So it becomes very, very small, all right, but it never crosses okay, what am I doing? I'm trying to zoom in. So it never touches the x-axis. So that's what you call an asymptote. All right. Okay, if you change the negative to a positive, look what's going to happen. The graph will now become going upward, right? Okay, so that's one way of double checking your answer. Double check, not to find your answer, okay? All right. So you have to know how to graph it by hand also or manually. Okay, so let's start with 0, 1, 2, 3, 4. Maybe you're wondering if we always have to start with 0. Not really. You can start with -1, -2. Okay, so can you tell me what's the first value here? Let's see if you guys remember where to find the first value. In the chat pod, find the first value. 2. Very good, Sean. All right, so the first value is whatever first number you see without an exponent. Okay, now be careful this time. Your base is 1/4. Your base is 1/4. So that means each time you're going to divide by 4. Okay? Or you can actually change the 1/4 to a decimal, which is what? A quarter, right? 0.25. Then that means you can multiply the previous number by 0.25. So I don't know which one you're better at. Either fraction or decimal, that's up to you. Okay. All right. Hi, Juliet. So hang on, honey. Is that the next number? Okay. So if you divide 2 by 4 or multiply by 1/4, okay, Juliet said is 1/2 or 0.5. That's great. Okay, so now you're going to divide that again by 4. What would that be? So you're dividing by 4 each time, okay? And then you have to divide that again by 4. What would that be? Oh, 0.03125. Okay, and then you divide that by 4 again. What's the answer? Oh, okay, 0.0078. All right. And maybe you're wondering, Miss, how do I graph that? That's so little. Okay. So since our highest value is 2, maybe we can spread out the scale a little bigger this time. Let's use bigger scale. So they're all positive anyway. So I'm going to put my x-axis right here all the way at the bottom and the y-axis over here. Okay. So since I want to show 2, this is 0.5, maybe I could go, maybe if I go 0.5, 1, 1.5, okay. I'll put 0.5 over here. And then this is 1. And then this is $1.25, and then this is 2. So I try to kind of leave, boxes in between or lines in between. Okay, these last few numbers will be very, very small, but at least we can show the graph, or we can see the shape. This is 1.5, okay, not 15. Okay, so let's graph that. When x is 0, y is 2. When x is 1, 0.5. Okay, when x is 2, it's 1/4 of a quarter, so this is half of a quarter, and then get half of that again, so somewhere here. Alright, and when x is 3, it's 1/4 of that. So it's like super, super small right here. And then 0, that's going to be like even closer to the x-axis. But again, it will never pass through your x-axis. So let's graph that one. Let's make a curve going that one, extend it, but don't go beyond the x-axis or don't go below it. There you go. And then it will extend over there. All right. Okay, and that's going to be the graph of 2 times 1/4 to the x power. Okay. So you don't have any delta math unless you have makeup work. What I'm going to ask you to do this weekend, I'm going to clear this one, okay? What I'm going to ask you to do this weekend is to practice graphing, because we're going to continue graphing next week, but with a little bit more challenge, okay? All right, so today we learn how to evaluate functions, like when you plugged in, right? Okay, and then this is where you're going to start graphing them. All right, excuse me. So these are samples on graphing that you can practice on. We haven't done writing an equation, but if you would like to practice on that, we can check your answers next week as well. Okay? Now, I put the link here where you can check your answers. Okay, so if you're working on the weekend and you want to validate whether you're getting it right or wrong, you can click on this link and it will take you to the website showing the answer or the link to the answers. All right. Okay, so just a quick one. Okay, I'm still missing a lot of names right here. If you guys have questions, let me know. Aiden is here. Giovanni is here. How are you guys? Why are you guys not putting in your names? Christian is here. Sean is here. Daniel is here. Erlinda is here. You can find this in Schoology, you guys. What if you're absent and you really cannot Zoom? So you're just gonna let me mark you absent because you're not signing in. Remember, if you sign in and even though you have problems in Zoom, if your name is here, you're present. Jasmine, nope. Joshua. Joshua, where are you? I thought I saw him. No? George O. No? Yeah. Okay. Mary Quinns are not here. Okay, who else? Trezzoli, Oscar. Valerie is here. Okay, did I miss anybody? I always forget to put my name. You should not forget, honey. Next time, I'm gonna like grade you based on your attendance also on this one. Not even allowed, maybe not. But come on, guys. If if I have to do it for one or two people, that's like okay. Maybe they really can't open it. But if I gotta do it for everybody, that's like I'm not happy with that. Okay, here we go. All right, did I miss anybody? If you don't see a P, where? I can't see it. Are you sharing it? At the top. Oh yeah, 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 yeah. Right here. Uh huh. So it shows me when you're in the form. Uh huh. That's cool. That's why I can see like when you last edited it and something like that. Okay. Cool. All right. Do you guys have any questions? Do you guys have any questions? I'm gonna send it again for attendance via remind. Just ignore it because you're here. So what do you have to do this weekend? Well, first have fun, and then after having fun, you're gonna catch up on your missing work. Okay, you have to catch up on your missing work. Um, Delta Math is one. I know you're missing some from Delta Math. Schoology, those little things with the puzzle, you have to work on those. Those are self-graded. So if you do them, it will automatically give you your grade. I will also be checking your OneNote. You've seen your Schoology grade book, right? Okay, so I'm not sure. Is it showing the letter grade? I might have to like hide that one if it's showing. Let me see. Oh yeah, it's hiding it. Okay, so you see here, like progress check. Some of you are missing it. Giovanni, you haven't done it. I'm gonna be putting all those zeros right there. Ooh, Jesus did it. Sorry, honey, I haven't updated your grade. There you go. See, I can easily update your grade if you do it. Your delta math are not done. You see all those bunch of zeros right there? Okay, Jesus. Is Jesus Lopez here? No. Okay. You have a question? Sure, honey. I will. I will. Can you like send it to me via remind? I think I did that last time you sent me, right? Okay. Yeah. So like when you send this to me, I can easily copy this into your OneNote. Forgive me if sometimes I forget, but you can see like how much message I got on Remind. So I'll try to catch up on that, honey. Um, yes. So I'm going to put it in your notes. I'll show you where. Weak exponent rules. Okay, so here on this untitled page, Cicely, I'm going to paste your. Okay, so it's. I think it froze. Okay, but I'm going to paste your notebook right here on this untitled page. All right. Mhm. You too. Anybody else with questions? Okay, guys. Happy weekend. Enjoy. Grades due on Wednesday, not Friday. Wednesday. Yes, honey? Yeah. Oh. What do you mean? Oh, it doesn't work that way, honey, because I have meetings after that. Like there's a PD from 1:15 to 2:15, and then there's a faculty meeting on Mondays from 3 o'clock to 4 o'clock. Okay, so let me show you my schedule for next week. I have you on Monday. I can put you on Thursday. Okay, but for Thursday, it's from 2:15 to 2:45. Does that make sense? Okay, already. You too, honey.